All right, we are ready for another day of math, and this is section 6.3, where we are going to add and subtract radical expressions. All right, this isn't too shabby of a section to learn, and learning, and that's what we're doing, right? We've had pretty good turnout for our first go-around with the homework, but I want to remember and remind you all that from my perspective, it's we've got to do it during our class time. Actually, I'm giving you a 4-hour window to do it on Tuesdays and Thursdays, but we have to be present during that time to do the homework. And that's kind of like what I'm doing the rest of this semester. So you watch the videos in between. Those are available on YouTube. I send you the link through the XYZ homework. And then you learn from that and then go to it on the homework on that given Tuesday or Thursday. So you manage your own time here. That's up to you how you're going to do it. Now, some students may do within the whole 4 hours, watch the videos and do the homework, or they may watch it ahead of time and take notes and kind of get the idea of what's going on before they start the homework. But remember, you must do it during that time. All right. And that's where your attendance comes in, and that's what I'm required to have you do. So you're coming to class, even though it's virtual, you are performing during class time. All right. Enough said about that. And let's go to radical expressions now. When we are adding and subtracting radical expressions, we want to first learn how to combine similar terms. So what does that mean? Well, two radicals are said to be similar or like radicals if they have the same index and the same radicand. All right, so this leads us right to our first example, where I have the problem is, actually it's, example 1. So let's start with that. And this is going to be to combine 5 times root 3 and minus 4 times root 3 plus 6 times root 3. Now, in this problem, of course, it's example 1, so they start us off with the easy one. And the radicals are all square roots of 3, and they're all simplified. So there's nothing to do here. They have the same radicand, which is the 3, and the same index, which is 2, it's a square root. So this already fits the criteria, and all I have to do is add these up. All right, so that's going to look like what? 5 root 3 minus 4 root 3 is going to be 1 root 3, or I could just written that as root 3 plus 6 root 3. And that's going to equal 7 root 3. And that's all there is to do to that, because it's an easy one. All right, let's go to example 2. All right, example 2. Now, this is a little bit different. This one, my radicands are not the same. The index is the same, but not the radicand. So what I want to do is I want to simplify both of these. All right, so let's take this 3 root 8. All right, so it's going to be 3 times the square root of 8. And what's the square root of 8? So let's see, let me get rid of that for a moment here. Let's just get rid of that, and I'll make that my workspace, I think. All right, so let's come over here, and our number here is 8, and I've got to break that down, and I know, again, that's 2 times 2 times 2. And so let's see, I've got for every 2 of the same number, 2 comes out, and then the 2 stays under the radical sign. So I've got 2 root 2. So this will be rewritten, the first term here is going to be written as 3 times 2. Here, I'll do it this way first. 3 times 2 root 2. Okay, you see the breakdown of the square root of 8 is 2 root 2. And this 3 we're going to multiply to the 2. So this ends up being 6 root 2. Okay, we multiply the 3 times 2 because we need to. And so that's the first term converted here. And now I've got to work on the 5 times the 18. So let's take the 18 over here on this side and break that down. So that's going to be, well, let's see, 9 times 2 is 18. And if I took the square root of that, I'll do this a little differently, big boy way, I guess. The square root of 9 is 3. And then the square root of 2, well, that's just going to stay under the radical sign. So this is going to end up being 3 root 2. Square root of 9 is 3. That's taken out. And the root 2 we're stuck with. Now this 3 is going to be multiplied to this 5. And this is going to look like 5 times 3 root 2. And now this ends up being, it's addition plus 15 root 2. And now our radicals are the same, and so are the indexes. So this ends up being 6 and 5, 21 root 2. And that is our second example. Okay? All right, so here's example 3 now. So they want us to subtract these two, same thing as combine, that's why they write combine. And notice this over here, let me change colors. Here's our parameters that x and y are greater than or equal to 0. That's telling us that we're going to use the positive square root of something as part of our answer. Real important for when we get to the latter part of this section, where we don't know if our answer is negative or positive. Mere formality, but it's like technical stuff that we want to know. Okay, so this is telling us that x and y are going to be greater than 0, meaning positive, and we want to subtract these two items. But to follow the rule now with radicals, we've got to simplify these radicals first. And we want our radicals to be the same, one with the same index. So let's try it. I can do this separately too as well. So now I got 75, and I want to take that over here. And let's go back to yellow because I'm weird that way. All right, let's try that. So I'm going to have 75, and when I break this down, it's going to be 25 times 3. All right, then I can say, what's the square root of 25 times 3? Well, the square root of 25 is 5. Let's see here. How do I get out of here? There. If I got square root of 25 is 5, so that means I'm going to have the 5 on the outside along with the 7. 7 times 5, root 3. Okay, square root of 25 is 5. That's brought outside. Square root of 3 remains the square root of 3. And this is multiplied by the 7, which is listed right here in the problem, of course. And we multiply that to anything I draw out of the radical. So this ends up being 35 root 3. And then I'm going to subtract that from the simplified version of 4y times square root of 12xy. So let's just bring the 12 over here. We're going to go back to the variable, so hold on with me. All right, so now I'm going to bring the 12 here and do the square root of 12. Well, I know that's 4 times 3, and I want to use the 3 because of this 3. Kind of gives me a little hint of what to do with that. Then I've got the square root of 4 is 2, so this is going to be 2 root 3. And there I can see I've got my radicals that are going to be the same. And then this 4y is going to come down here because I'm going to multiply 4y times 2. All right, this is where I'm at thus far. Taking care of the numerical values first. And then let's see here. I've got the square root of x. Well, that tells me I've only got one x there, so one's going to stay in, that one x is going to stay inside. So let me put it here. And then let me dial this up here a little bit. The luxury I have writing with this tool that you don't. All right, then I'll extend this. And now I've got, what's the square root of y to the third? Well, for every 2, you take out 1. So that means 1's going to be outside here. How about if I write it here? And then 1 is going to remain inside for this term here, the first term. Okay, so that's looking good there. And on this right side here, I've got xy, so that's just going to stay inside. And I'm going to leave it as x, xy. And notice my radicals are the same. So let's just kind of first touch up something here and get ourselves on the same page. So I've got 35y times root 3xy minus, well, 4y times 2 is 8y times what? 3xy. So, how do you like in this? What do you think my answer is going to be here? I've got 35y blah, 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 minus 8y square root of 3xy. So this is going to end up 35y minus 8y, which is 27y times the square root of 3xy. So that worked out real nice. I've got these two terms are like terms, and I've got 35y minus 8y. That gives me the 27y along with the radical of 3xy. Okay. Let's move on to our next example 4. Okay. Here is example 4. I don't know how many I got. I didn't look. Let's do some simplifying work on getting these radicals to be the same. All right, so a 10 on the outside here, and it's a cube root this time. So, oh, look at this. I've got a cube root of 8. I already know what that is. If I bring the 8 over here, I know that's 4 times 2, and 2 is prime. Then the 4 breaks down to be 2 times 2. So there I've got 2 times 2 times 2. So 1, 2 comes out. I'll just work on that. I know that I'll multiply the 10 later. All right, so I got 2, a to the 4th. This is the cube root of a to the 4th, so I could say 3 goes into 4 one time with 1 left over. So that means one of the a's is going to come out, and one of the a's is going to stay in the radical. And then I've got b squared. Well, the cube root of b squared, there isn't a cube root of b squared, so the b squared stays inside, under the radical. Can't take 1 out because I don't have 3 of them. So that's going to stay put. And now, let's see, I'm going to have that 10 multiplied to the 2a. So what have I got here? 20a times the cube root of ab squared. And that's why it's important to put that index number there so we know what index it is. I'll jot it back there too. Okay? It's an easy thing to do is not put the index number there. All right, let's move on to the right side. So this is an addition sign, and let's figure this one out. I've got 11a here. I'll tend to that in a moment. But I've got the cube root of 27. That's 3. And then it looks like what's going to stay under the radical sign is the a, because that's just a to the first. I need 3 of them to take 1 out. Don't have it. Here I have 2 b's, b to the second, and I don't have 3 of those to take 1 out, so that's going to stay under the radical. And in turn, it makes our, well, let me put my cube there, it makes our radicand and index the same. Okay, and that's what we're looking for. And now I'm going to bring down that 11a here, and just so I can multiply it together to give me 33a times the cube root of ab squared. Okay, and this is where I'm at this moment here. Okay, everything's, now I just have easy addition. 20a plus 33a is going to give me 53a times the cube root of ab squared. And that's how lovely it is. This section isn't bad. It's quite fun, actually. When you get into focus here and concentrate on what you're doing, it's rather interesting. All right, so that was example 4. Okay, example 5, it's just saying to combine. Combine the square root of 3 divided by 2 plus 1 over the square root of 3. They're fractions. We're adding 2 fractions, but we got to get the denominators to be the same. So I hope you know how to do this one before I actually do it. Because what I'm going to do is I'm going to, I'll take a moment. Maybe you could push the stop button or pause button and try and do this one on your own before I work it out and see what your answer is. Okay. Let's see. I want to get the denominators to be the same. So I'm going to multiply this 2 by the square root of 3. And again, top and bottom. The square root of 3, I'm going to multiply by 2, top and bottom. And you know where I'm getting these numbers. The 2, to multiply a number by 2, I'm just looking at the other denominator and multiplying them together. Because then when I see I do it to both sides, I'm going to have a denominator of 2 root 3. Okay, let's see. Moving on. This is not an equation now. I don't see an equal sign, or I don't see it equal to something. That's the difference of when you can ignore the numerator, like I taught you when we're doing equations. This are just an expression. Even if I did have an equal sign here with nothing here, well, that means I'm going to include my denominator as part of my answer. It is still just the expression that we're talking about here. All right, nevertheless, let's continue on. So now I know I've got what? I've got my denominator is going to be 2 root 3, because that's what it's going to equal to. They're the same now at that point. And let's figure out what I got up top. Square root of 3 times the square root of 3 is 3. Plus, what is this? 1 times 2 is 2. And I've got 3 plus 2 is 5. All right, so I've got 5 over 2 root 3. But I'm not quite done yet, am I? What's wrong with this? 5 over 2 root 3. We have to get rid of that radical sign in the denominator. So that means I've got to rationalize the denominator. And that means, again, I'm going to multiply the top and bottom by square root of 3. I'm going to leave the 2. I don't have to multiply that by 2 root 3, just the radical. So this is going to be root 3 over root 3. And now when I finish this, this is going to look like my denominator now is going to be 2 times the square root of 3 times the square root of 3. The square root of 3 times the square root of 3 is 3, and that's going to be multiplied to the 2. Okay, the top is 5 times root 3, which is 5 root 3. And then I just have to touch this up a little bit by getting my denominator multiplied out. So here I've got 2 times 3 is 6, and my top remains 5 root 3. And that is my answer for example number 5. Okay, part B is about the golden rectangle. Really not good. If we were in class, I'd do that with you, but you know, it's not too bad. I'll look in our objectives, make sure we don't have to cover that. Just something interesting, golden rectangle. The optimum framing for taking pictures perhaps, or a movie screen. That's what the golden rectangle is about. They have that figured out. What's the optimum dimensions of a picture that's the best to look at? And they've always come up with the golden rectangle. From the Greeks. Okay, well that's it for today. This is it on 6.3. 5 examples, and check it out. Good luck with that. And remember, that's going to be done on Thursday, 6.3. 6.2 is going to be Tuesday. That's when you're going to work on those assignments. And I apologize again for the me having to get hard on you guys with the combination of not being in class and having to do this because of the virus that's going around, that we have to do this remotely, they're calling. All right, but I have to have you in class, and that's when you have to do the homework. So if you cannot make it, I don't know where you are, but maybe if you're working or something, you gotta bite the bullet on that one. I can't change it and change the times. You're supposed to be in class during that time, and that's how the school's looking at it, and me too. Okay, that's it for now. I will talk to you sometime. Whoever contacts me, I will talk to. All right, farewell. Be well. Stay safe. Stay away from people. Okay. Have a good day.